All right, here we go. Algebra 2, Algebra 2 with practice B from section 5.3. That's quadratics. All right, we're talking graphing here. Let's do it. Let's graph. All right, so what do we have happening? I have this, find the zeros of each function using a graph and a table. So I really just need to plug it in. So I'm going to plug in these numbers, see if I can figure out where the zero would be. So plug in -4. That would be -4 squared, or 16. And then plus 5 times -4, that's -20. And then we got plus 6. Hey, check that out. That's not too bad. That gives me 16 minus 20 plus 6. That's 2. And the next one, if I were to plug in -3, that'd be 9 minus 15, and then plus 6. Ooh, that one looks good because 9 and 6 makes 15. 15 minus 15 is 0. 0. Check it out. So there's a 0 at -3. All right, let's keep going with this pattern. And let's see what we would get at this next one. It says -2. So let's plug that in. We'd have -2 squared, that's 4. Plus 5 times -2, that's -10. And then plus 6. Hey, check this out. Check this out. We got another 0. And then we got -1. Now, here's the cool thing about parabolas. They got some symmetry. Notice how it goes 2, 0. This should go 0, 2. Let's double check, but this should be a 2. I'm going to do this one down here. This would be, well, if I plug in -1, I get 1 for -1 squared. We got -5 for that middle term, and then plus 6. So we got 1 plus 6 minus 5. That's 2. It is 2. The last one is probably the easiest one. You plug in 0. You got 0 plus 0 plus 6. So that's just 6. That was easy. Okay, so we got an intercept here at 6. We got zeros at -3 and -2, which is actually here and here. And then we have values of 2 at -4 and -1. So that's what that graph looks like. We'll draw this one in black. I think I'm going to do the next one in a different color. It barely crosses that line and comes right back. It only crosses it just for a tiny bit. Let's do the other one. How about in red, just to differentiate here. So we got -x squared plus 4x plus 5. Okay, so I'm going to plug in these numbers, see what we get. -x squared, that's negative, and -2 squared is 4. Plus 4 times -2 is going to be -8. And then plus 5. What's that give me? Well, -4, -8, that's -12, plus 5, that's -7. When we plug in 0, that puts us all the way at 5, because that's 0 plus 0 plus 5. What happens when we plug in 2? Well, if we plug in 2, that's still going to give me -2. So for this one, it's going to be 2 squared and then negative, so that's -2. 4 times 2 is 8, so that's plus 8 this time, and then plus 5. So we got 13 minus 2, or 11. And then for the next one, we plug in 4. Let's see what happens there. So 4 squared is 16. Negative is going to be -16. And then 4 times 4 is plus 16. And then we got plus 5. So this is kind of interesting. I almost feel like I made a mistake here in the middle. But I'm not sure. Not sure. Maybe it was this one that we made a mistake on. We got -4. Oh, this was -4. That's why. That's why that one looks so weird. Knew that number was off somehow. So that's a -4 because 2 squared is 4. Negative is -4. Then we got plus 8 plus 5. So -4 plus 8 is going to be 4. And then plus 5, that's 9. That looks a little better there. Let's start graphing what we have. See if something pops in here for us. Okay, so at -2, we're at -7. That's like down here. And then at 0, we're at 5. That's way up here. And then at 2, we're at 9. About there. And then we're back down Now I'm guessing at this 6 that we're going to be back down at -7. So it looks like we're crossing right about at -1 maybe. Maybe at -1 and at 5. Well, let's see what would happen right in between these if we were to plug in -1. Well, -1 squared is -1 times -1. And then times this negative is just going to be -1. Lots of negative ones there. Plus 4 times -1 is going to be -4. And then plus 5. That does equal 0. So the 0 is right here in the middle at -1. So that's one of them. And if that's right between 0 and -2, I'm willing to bet that the other one's at 1. I betcha. What is it? No, not at 1. Right here, between 2 and 4. No, not between 2 and 4. Between 4 and 6. It's going to be at 5. Right there. That's the other 0. So we have 1 0 here. We have another 0 there. At x equals 5. All right, so that's graphing. Basic idea. We're going to do some more kind of advanced work through here as well. So let's take a look at these. So find the zeros of each function by factoring. So factoring is fun, I think. Let's see what we can do, and let's talk some strategy. Okay, so if I want to find the 0, the thing that I do is I set it equal to 0. So I'm going to do some scratch work here. This would actually be a good time for you to get out some scratch paper, because I'm going to use this space below for my scratch paper. So if I set it equal to 0, 0 equals -x squared minus 6x minus 9. It is so much easier when that thing is not negative. It just kind of throws everything off. So what I'm going to do is I'm actually going to move all this to the other side. Here we go. So plus x squared plus 6x plus 9. That would give me x squared plus 6x plus 9 equals 0. This now is doable. I can multiply to 9 and add up to 6. And how do I do that? Well, this is a positive 9, and that means these have to be positive. And that would be a positive 3, a positive 3. So I would have x plus 3 times x plus 3 equals 0. Now, if I were to solve that, I just have to do x plus 3 equals 0. So x is going to be equal to -3. So I'm not finding zeros. There's only one 0, but it kind of happens twice there. All right, let's look at the next one. This one is ridiculous because I look at it, and I used to do this as a guess and check kind of thing. That's how I learned it back in the day. But as I've taught this, there's actually been some things that I've learned a little bit differently. And really what's happening is kind of tied up in this number up top, because that number, usually we take the C, and that's what that is right there. And I say usually because there's another thing you can try. So take a look at this. And this is something worth watching multiple times here. We're really going to take that top number, and it's going to be A times C, and down here is B. And if this A equals 1, if A equals 1, it's not a big deal. But if A does not equal 1, now let's see what happens. So I'm going to split this up. And my A here is 2. My C here is 4. So that's 2 and 4 multiplied make 8. And then this is going to make 9. And how does this really help me? Well, let's see. I would try to multiply to 8, add up to 9. That would be 8 and 1. Okay. I got that. But this isn't really x plus 8 and x plus 1. But what you can do, look at this. 8 and 1 add up to 9. And what this shows is how you can split 9 up and do a different kind of factoring. So I'm going to have 2x squared. I'm going to split that 9x into two terms. It's going to be plus 8x. And then we got the other one is plus 1x. And then the last number is plus 4. Now I'm going to do this kind of in two groups. Let's call it like a red group and a blue group. So I'm going to do the red group, and then I'm going to do the blue group. Change the blue here. Blue. The blue group. So for the red group, I want to see what can I factor out of these. Well, it looks like I can pull out a 2x. And that would be 2x, and then what would be left over? I'd have x here, plus, and then 2x times something equals 8x. That'd be x plus 4. Okay. Now let's take a peek at the other one, the blue group, plus. Now over here, I can't really factor out anything except like a 1. So I'll go ahead and write that 1 there, but that'd be 1 times x plus 1 times 4. And there we go. But here's the awesome part. Oh my goodness, it's so awesome. Check this out. We got green, green. See those things? X plus 4. So that's like x plus 4 is now a factor. It's something that both of these outside pieces are multiplying to. It's this x plus 4 that they have in common. So I'm going to factor that out. I'll factor that out here. X plus 4. And then now let's see what's left over. Well, the first term is 2x there. And then the second term is plus 1 there. Hey, check this out. That is cool. I just factored it. That's how it works, guys. Okay, so now if I set this equal to 0, I could set each of these pieces equal to 0. And I would have x plus 4 equals 0 and 2x plus 1 equals 0. And then I'd have x equals negative 4 from this one. And for the other one, it's kind of 2 steps. I have 2x equals negative 1, divide by 2, divide by 2. And then we got x equals negative 1 half. X equals negative 4, x equals negative 1 half. Awesome. Okay, I promise number 5 is actually easier. Ready? Okay. Here we go. So we got x squared plus x minus 20. So we got to multiply to negative 20, but add up to positive 1. Okay, what kind of numbers multiply to 20? So we got like 4 times 5. We got 2 times 10. We got, is that it? Yeah, that's most of them right there, because 5 times 4 and 10 times 2 is pretty much the same thing. We could do 1 times 20. That doesn't really help. Okay, so how could I mix some positives and negatives and make plus 1? Well, it looks like if I have a plus 5 and a minus 4, that would multiply to negative 20, but add up to positive 1. So I'm going to translate these into x minus 4 times x plus 5 equals our g of x. Now we're going to make that equal to 0. So 0 equals x minus 4 times x plus 5. There we go. Okay, so x minus 4 equals 0, x plus 5 equals 0, and then that gives me x equals 4, x equals negative 5. Check. Super cool. Super, super cool. All right, so let's look at the next things right here. It says find the roots of the equation by factoring. Okay, so let's see what we got going on. Let's do number 6, and we'll get all the way to number 9, and then we'll just kind of finish there. So let's look at number 6. It says 12x equals 9x squared plus 4. Now this would be easier if this was 0 over here. So I'm going to take this 12x and move it over. And in fact, I'm going to kind of cover up my space down there, remove all those distractions. So this would be rewritten as 9x squared plus 4 minus 12x equals 0. But that doesn't make as much sense because we usually have that x to the first power in the middle. So let's do that. 9x squared minus 12x to the first power plus 4. And that equals 0. Okay, a couple of things happen here. In fact, this does fit one of those patterns from the last one. But I'm going to do the crazy thing, that whole like split the middle thing, where I have A, C on top and B on bottom. So I got to do A times C. Here's my A times my C. 9 times 4 is going to give me the top. So that'll be a 36. And then the bottom is that negative 12. So what multiplies to positive 36 but adds up to negative 12? Well, that would be negative 6 times negative 6. And now, folks, we have our split. the negative 12 is going to split to 9x squared minus 6x minus 6x. We're splitting it with those two negative 6's. Plus 4. All right, so let's see what we can factor here. The 9 and the 6, a 3 goes into each of those. And an x. So I pull out the 3x. What would we have? Well, this would be a 3x again, because 3x times 3x is 9x squared. And then the other one, 3 times negative 2 gives me that 6. And then x times that gives me the x. So I want to make it look like 3x minus 2 over here. I think I can, but let's see what we come up with. So if I have this negative 6x plus 4, but I want it to be negative 2 and a 3x, what times negative 2 equals 4 positive? That would be a negative 2. And let's see if that works the same for the other thing. Negative 2 times 3x equals negative 6x. That is true. Awesome. So now let's factor this. Notice what we have in common for each of these. We got this 3x minus 2, this 3x minus 2. So we can take that as one of the factors, 3x minus 2. And then the other one is pieced together by these two pieces there, which is also 3x minus 2. So 3x minus 2 times 3x minus 2 equals 0. Now, folks, what's happening? Well, 3x minus 2 equals 0. We got to solve that. And we add 2, we got 3x equals 2. So x equals 2/3. Piece of cake. Upside down. There we go. All right, now this one, I'm going to cheat. I'm really going to cheat. I'm not going to do the perfect square thing here. I'm going to just say, let's divide by 16. Then I would have x squared equals 9 over 16. I'm going to square root that. And I'll say x equals, well, that's the square root of 9 over the square root of 16. But wait, that's just 3 over 4. But because we took the square root, we don't know if the original number, x, was positive or the negative. So we got to say it's both. So x is actually two answers. X equals negative 3 over 4, and x equals positive 3 over 4. Okay, one more little bit here, and then we are wrapped for the day. So let's scroll down just a little bit. Not that far, just a little bit. There we go. I'm going to cover up this bottom piece so we're not too confused by what's going on. Write a quadratic function in standard form for each given set of zeros. Okay, so we got negative 2 and 7. And what that is telling me is that I got this. These are my zeros. So x equals negative 2 is one of them. And x equals 7 is the other one. So now we got to build it backwards. If I were to add 2 to both sides here and subtract 7 to both sides there, that means that I had x plus 2 equals 0 and x minus 7 equals 0. Okay, so there's my two factors. So the two factors were x plus 2 times x minus 7. Now there's a lot of ways to do this. I tend to stick to the box style multiplication where you just kind of group these things. And it's really doing distributive property but in an organized way. So we're going to have one set up here, x and then positive 2. Then the other set down here, x and negative 7. Doesn't matter which one was where. But now we're going to multiply each of these in the intersecting boxes. So x times x is x squared. 2 times x is 2x. X times negative 7 is negative 7x. 2 times negative 7 is negative 14. There we go. So that's what we got. Well, wait, we got to combine these because those are like terms. So we have x squared plus 2x minus 7x minus 14. And we combine these and we got x squared minus 5x minus 14 equals our function. So let's call it f of x. There you go. Okay, so for this last one, same idea. We start out with x equals 1 and x equals negative 8. So we got to do some algebra to work backwards. I'm going to add 1, or subtract 1, add 8, add 8. That gives me x minus 1 equals 0 and x plus 8 equals 0. Then I got to multiply those. So x minus 1 times x plus 8. So x minus 1 times x plus 8. And now I'm going to do my little box. So I'm going to take this box. And now I'm going to multiply. So I got this x plus 8 and this x minus 1. Well, x times x is x squared. Cool. X times negative 1 is negative 1x. X times 8 is 8x, positive. And negative 1 times 8 is negative 8. So if I were to write this out, I would have x squared minus 1x plus 8x negative 8. So there's my 4 terms. I can group these middle ones. That's cool. So x squared plus 7x minus 8 equals, let's call it f of x again. All right, so that's that. That's what we got. You can try practice C. I'm going to say that practice C is bonus because that's where the hard ones are. You thought these were hard. But the homework is also given to you guys through your email and up on the board as well. So there we go. That's it. That's all we got for today.